My name's Doug. I did a heavy metal subgenre classification.
A gesture-controlled music browsing system in 3D space.
Grabs images from the internet and automatically determines if they're music scores.
And then these are the power-ups.
To come up with a self-organizing map.
Probably how much music transcription is.
This wheel here controlling
Audio time-limiting utility that would be like a web experience.
My name is Thor, and I'm going to talk to you about playlisting and playlist ordering algorithms.
Chaos theory is actually pretty easy to implement.
My project is working on music-to-music classification using audio feature and lyrics.
Recommendation of new major chords.
How many hours did you guys waste trying to find parallel to this?
You can simply parallel processing of modified discrete Proton transform.
Guitar chord transcription app
For a robot, those little details are just real colors.
Basically, that's put a bunch of tracks in, and then we take all that data and give you the best possible results. So, give me some music.
Right now it's spawning two different threads that are actually going through and stretching the side on the right and compressing the audio on the left. And so, like I said, it takes a little while just because it's actually doing it within the browser with JavaScript. And we'll try playing this.
If there's a score and then some text, it will find the score.
So that this would be in the set of the positive output. So up here is pop music. I know it's pop music. So you can kind of like move around these spaces. Classical music. It's pretty fun to play with. We zoom back in our work now.
I'll turn the time back over to George.
Here is the dictionary from a paper which studied attractive nouns for English words.
There's a different, you can tell there's a difference. So it's just trying to classify that.
So I can drag the pad into the map, so where we have such tags will highlight it. And you can use multiple tags as well, which just do the AND operation.
The 10 bins that we found from lowest frequency to highest frequency. And we say what is the difference between the first bin and the second bin, or the first and the third, the first and the fourth, and so on. And we basically do the permutation of all these 10 numbers, which ends up being 10 choose 2 or 45 elements. So these are the features we end up using.
So I tried again with front, zero process, flux, and rollup. When I summarize them with the mean, I got 67%. And summarize them with standardization and command, I set 4% classification rate. This is all using this 4 vector machine in the back there. As you can see here, I basically just using 2 clock cycles, I can perform the same computation. Well, this is rather simple idea. When you want to have it running on processes like this, you're going to face many problems, such as you have to be able to pass. So in order to take advantage of that much processing power, you have to be able to match the starting point addresses of all your data into the memory bin.
It's used for audio source separation, which means if you have a sound that is mixed of several sounds, and the sounds are like from different sources, it's really difficult for a machine to do it. It's important to be able to separate those sounds. You probably have heard of the cognitive problem, which means like if you are recording and several people are talking at the same time, it's really easy for human
And the numbers on the left are kind of meaningless.
Do it, Tori.
It only works in Firefox.
He actually died from a lava lamp.
My slides are not even as beautiful as Gabby's, so
Try to chrome with the kicks.
Deeming their discoveries after themselves, I refer to the 45 element vector as the Harpin vector.
Not to play devil's advocate, but why would you say cheaper, Jeff?
the speed up that I got with using this method was about 10 times, 1 order of magnitude.
It comes down to just using more CS.
Stayed all night long trying to figure out what to do.